Okay, so here we are with example 3. We have a moon rotates twice every 48 hours around a planet with a mass of 5.98 times 10 to the 24 kilograms. So a really massive planet, similar to Earth, at a distance of 6,655,000 meters from the center of that planet. Find the acceleration of the moon. Okay, so what we want to do is take a look at what we're given. So in our first sentence here, we notice that the moon rotates twice. Every 48 hours. Okay, so that means that our frequency, our normal frequency here, all right, what's happening? Okay, our normal frequency here is 2 revolutions every 48 hours. So if we simplify that, that's the same as 1 revolution in 24 hours. Okay, we're also told that the mass of the planet Sorry, let's go back and fix this for a second. So we want okay, so moon rotates every 48 hours of a mass. So moon rotates twice every 48 hours around a planet. The moon has a mass of 5.98 times 10 to the 24th kilograms. The radius is 6,655,000 meters from the center of that planet. Find the acceleration of the moon. Okay, so just change the moon's mass is 5.98 times 10 to the 24th. Okay, ignore the mass of the planet. We'll talk about that in the later unit. Okay, so our frequency is 1 revolution per every 24 hours. We're also told that the mass of our rotating object is 5.98 times 10 to the 24th kilograms. Okay, the radius of rotation, so distance from the center, is 6,655,000 meters. We want to find A. We know that A is equal to V squared over R, but we don't have V. Okay, so the first thing you need to find is our tangential velocity. We know 2 things about tangential velocity. It's equal to the arc length over the time, or it's also equal to 2 pi r over the period. So the circumference over the period. Okay, so we're given frequency. So we're given frequency, we can find the period. So we're going to want to use that second relationship for velocity that we just talked about. We want to use 2 pi r over the period. First, we need to find the period. We can find the period using the frequency. We just need to get it into the correct units. Okay, so we're going to focus in on our frequency. We need it in revolutions per second. Okay, so we're going to figure out how many seconds it takes to make 1 revolution. So we know that in 1 hour, there are 60 minutes. Okay, and then in 1 minute, we have 60 seconds. So we multiply that through, hours are going to cancel, minutes are going to cancel, we left with revolutions per second. We know that 1 revolution is going to take 86,400 seconds. Okay, we know that technically, right, our frequency is equal to 1 over our period. So this right here is our period. It's going to be 86,000. 400 seconds. So now that we have our period, we can find our tangential velocity. So let's start there. We're going to use this equation here. So V is equal to 2 pi r over our period. That's equal to 2 pi times the radius, which is 6,665,000 meters, divided by the period, 86,400 seconds. Okay, so we multiply that through, we're going to get 484.7 meters per second. Okay, so now that we have our velocity, we can now go back and we can solve for our acceleration, okay, because we know it's equal to v squared over r. So let's go ahead and do that. So our acceleration is equal to v squared over r. That's going to be equal to 484.7 meters per second squared, divided by the radius, which we're told in the problem is 6,665,000 meters. Okay, so when we plug that into our calculator, 484.7 squared divided by 6,665,000 meters, we are going to get an acceleration of 0.04 meters per second squared. Okay, so we could further apply that. Let's say we have a part B, and in our part B, it asks us to find the centripetal force that causes this acceleration. Okay, so if we want our centripetal force, F sub c, that's simply equal to m times a. We have a, we define F sub c. So centripetal force is going to be equal to 5.98 times 10 to the 24 kilograms times 0.04 meters per second squared. So our centripetal force is going to be equal to, I forgot to say this before, but make sure when you add the masses into your calculator in scientific notation that you're using that EE button. So what this should look like in your calculator is 5.98 E 24. Okay, that's equivalent to 5.98 times 10 to the 24th. So make sure you're using that EE button or you're going to get the incorrect answer. So for the force, we multiply those two numbers, we're going to get a really big force, 2.4 times 10 to the 23rd newtons.